Hello everyone, Fru here. Welcome to today's lecture. So guys, in today's lecture, we are in module 6. And in this module, we're going to be talking about functions and methods within Python. There are a lot of concepts we're going to be covering around functions. And some of them includes just understanding what the difference is between functions and method, how to define and call a function or user-defined functions, or UDFs, that's a short term for it. We're also going to look at parameters versus arguments. So this is something that usually comes up. What is a parameter? What is an argument? We definitely want to understand that. And then we're going to look at certain examples of defining functions and passing parameters to functions. So we are going to look at default arguments, required arguments, keyword arguments, passing a variable number of arguments to a functions, defining global versus local variables, trying to understand what's global, what's local, the visibility of variables within a function, how to pass by reference or pass by value to a function. And then we're also going to look at return statements, look at anonymous functions or lambda functions, very powerful. And then we're going to look at pass statements and recursion. So guys, a lot of things to cover within this topic, just because function is a very powerful concept within Python or programming in general. Once you start getting to bigger programs, the things that we've been doing of just writing scripts on the screen is not going to pass, right? We're going to have to encapsulate logic within functions and try to reuse that logic over and over. As always, guys, all this code is available within my GitHub repository. So if you want to get access to all the scripts that we're going to be talking about today, just check into my GitHub repository. The link is going to be in the description. A lot of the examples, I put in a link in here for some very powerful reading, and some of the examples that we're going to go through were inspired by this content. So definitely check it out. That's datacam.com, and the link is on the screen right now. So, but if you go into my GitHub and be able to pull my code, you have all the access to the content that we're going to be covering today. So that said, let's get into our very first concept, which is to talk about functions versus methods. So on the screen here, I have a definition. Let me actually zoom in here, make this next line. All right, and then zoom back out. So it says a function is a piece of code written to carry out a specific task. That's a function. All right, and we're gonna see examples of that. Now, for method, it says a method, and this definition just came from a quick Wikipedia Google online search, so nothing really fancy. So it says a method refers to a function which is part of a class. All right, so that's the difference. So a function is just a piece of code to carry out a specific task over and over, but the method is just a function, the same as a function, but it's attached to a class. It's part of a class. Now, if you don't know what a class is, don't bother. We're going to be covering that in our future. I think that's going to be in module 8, where we talk about classes and object-oriented programming. So that's coming along, but just understand that a method is just a function associated with a class. You can access a method with an instance once you instantiate the class. So if you take a class and you instantiate that, it becomes an object. So once you instantiate the class, you can access the methods of the class. All right, a function doesn't have this restriction. It just refers to a standalone code. So there you go. So the difference between a function and a method, and this will become very clear as we dive in. So that said, let's go into our very first concept within this particular lecture. And I'm going into the working area here to look at that concept of a function. For this one, we are going to do something, right? We're going to get two numbers, A and B. Let's make A 5 and B, say, how about make B 3? All right, now we can go ahead and say print A plus B. All right, this is what we've seen. We're just kind of setting the stage here. We've seen that in Python we can do something like this, and if I go ahead and run this code, it should print us A plus B. Now, what if I want to make this in a way that's reusable over and over without me having to go into this print statement and write print A plus B? It can really be problematic over time. All right, now we can take all of this, wipe it out. All right, and then instead define a function. And the way we define a function is simply the syntax for defining a function within Python is def. All right, just simply start. So we want to go all the way to the far side of the screen, and this is important because if you don't do that, you might have issues. Say if I go space and start trying to define function like this, you might have issues. So we go all the way to the far side of the screen and we say def. All right, so that's simple. Give it the name of the function, any name that you want, but it just has to follow certain criteria. As we've seen a little bit earlier, we cannot be doing numbers in front and doing things like that. So Python has some of those restrictions. So we can define say def, which simply means define def, and we call this function plus. Now a function must take some arguments. Well, not must, but in this case we're gonna take some arguments. If you don't want any arguments, we can leave this blank. If you want arguments, now we can say, okay, we're gonna take 2 arguments. We're gonna take 2 parameters. Let me use the terms correctly, so because we're gonna discuss what the parameter is. So we're gonna take 2 parameters. One is a and another parameter will be b, and then we can go ahead and end that function. All right, so that's what we have. Now what are we trying to do? We're trying to return a plus b. Okay, so this is what our function is doing. It's going to return for us a plus b, or we can simply say return a plus b. Perfectly fine. We can put it in the bracket or choose not to put it in the brackets. Some people feel that, you know, putting in the bracket makes it easier to read. Now that we have that, this is basically what our function does. You give me one parameter, give me another parameter, and the function is going to take this, is going to add a and b, and is going to return it. Okay, so you might be saying, but Fru, how do I actually use this now? Okay, so we can go down on the screen. Again, we're going now 1 line back to the indentation, because indentations are very powerful within Python. So we're going now 1 line out. So this ends that function. That function is defined, but we need to call it to see something. So now I can say let's say y, say z equals well, let's just actually call the function directly, and then I'll call it with parameters. So we can go ahead and say print, and in this case we can go ahead and say plus. Now we want to add 2 numbers, 5 and 3. All right, so I can say plus 5 and 3, and I'm gonna print that on the screen. So what's happening here is gonna take or we can say x equals to plus 5 and 3. All right, maybe I should put it that way so it's very readable. Then we can go ahead and print x. So what happens once we say x equals to 5 plus 5 and 3? Now it's gonna pass 5 and 3 into our function. Our function takes this number 5 and 3, it adds them, and then it returns a value which is 8. And now 8 comes and is set to x, and now we'll print an x. All right, that's what functions really do for us. Now we've taken this logic of addition, we've encapsulated it into a function which is plus, and then we can call this plus anywhere in your code. If you need to add 2 numbers, you just say plus, and then you give them the number, your function is called, and then there you have it. All right, guys, so this is why functions are very, very, very powerful. Now let's talk about methods very briefly. We're gonna see a lot of examples of functions, but let's switch gears here and talk about methods, because methods are another concept within Python that comes up a lot. So what I'll do is I'll go ahead and comment out this piece of code here, so we can define a new line of code, which is gonna be a class. Defining a class might not make sense for this lecture, guys, but bear with me. In the next lecture, which will be module 8, we're really going to be diving into classes a lot more. So let me just do this very quickly and define a class. We're going to call that class. If it doesn't make sense again, just bear with me for now. Let's call that class summation. All right, and we're going to pass it an object. So within that class, we're going to define a method, and we're gonna call that method sum. We'll pass it as self, and in addition to that, we'll pass it 2 numbers, a and b. Then now we're gonna do self the content equals, set that to a, so we're gonna add a plus b, and then let's simply return self dot content. All right, so this is our class. We've just simply defined a simple class here. Let me make a comment out here. Class definition. All right, so this is our class. Now we can actually, in this class, we've done a definition here called sum. So this is our method within this class. Now I can go ahead and instantiate this class to say sum instance equals to, and that's just a variable name, equals to summation, right? So I'm simply just instantiating this class, and there's no parameter to pass. There's no argument going in there, so the class is doesn't take an argument, so it's just summation. Now I can say, you know, let's go x equals, let's do sum instance. All right, let's not do sum, we're gonna do sum instance. So we need that. I like to specify it fully. Dot sum 5 and 3. All right, and then we can go ahead and run that. Well, I need to print x on the screen, don't I? That's why we see nothing. Print x, which is the result. All right, so if I run that, we go ahead and we see 8 on the screen printing. So I can even do that without this. I think it should still resolve to 8. Oh, okay, actually it doesn't, so we need that in there. All right, so what is happening here? Up here I've defined a class. So again, if we don't understand what a class is, this is really just an abstraction within Python. Under object-oriented programming, we're going to cover it in a future lecture why classes are very important. But again, it's simply a further encapsulation of logic one level above a function. So if you think about a function being an encapsulation of logic, a class is just one level above that. But we're going to talk about that in future videos. So once we've defined our class, the class can have several methods. So in here, this is still a function, but because that function resides within a class, we tend to call it a method. So if you're going for an interview, or you know at your job, and somebody's talking about a function and someone else is talking about a method, then there you have it, right? If it's just not within a class, it's a function. If you start seeing a definition inside of a class, then that's a method of that class. All right, so here we've defined a method. Now this method takes two parameters. Again, a parameter is the variables that show up during the definition of that function or method. So these are two parameters, A and B. We can ignore self for now. So I'm taking the parameters, we're setting that parameter, we're adding the two parameters and setting it to some variable. Again, we're using self there just because it's in a class, and then we return that value. So now to actually access this method, we need to instantiate the class. So here we're saying some instance, right? So we're simply creating an object. So this is called an object of that class. Once you've instantiated the class, that becomes an object. So some instance equals summation. So this is just a method for instantiating a class. And now we're saying x is equal to some instance dot sum. So this dot sum is simply telling us that we're trying to access this method. We're accessing this method within this class, and we're giving it two arguments for it to do the summation. So here, this is parameters. Parameters is simply what is used in the definition of a function or a method, as I mentioned a little bit earlier. Now, once you're passing in specific values to your function or method, those specific values are called arguments. Now, that's the difference between a parameter and an argument. Parameters in the definition, arguments is an actual value that you're passing for that function to do something with. All right, so here we're passing two arguments into that function, and then so the function does its summation, which is the sum. It returns the result for us, and that result is x, and then we can go ahead and print x, which is why we have 8, right? If I change this to 15, all right, it still does the summation, and we go ahead and print 20. All right, so guys, there you have it, the difference between a function and a method, which is really what this lecture was talking about, right? We've understood functions is simply plain definition of something. You can just simply call it. There's nothing about classes in here. It's very simple, not anything complicated. All right, def, you can give it any name. You can say def, you know, so let's say special plus, right? Whatever name you want to give here, that's the name of your function. And then if you say special plus, you come in here and you can simply call special plus any way you want. All right, so you have your parameters, which is what the function definition needs, and once you actually calling that function, you're passing in arguments. So that's the difference, parameters versus arguments. And then we've seen functions versus method. This is a function, a method is simply a function within a class. All right, guys, I hope this helps. This is something that especially for beginner programmers, they kind of always confuse this a lot. At least to me, it was confusing back in the day when I was simply just doing Java and certain other programming languages. This concept was a little bit confusing. I know the class idea might be confusing, but we'll certainly cover that in future videos. That said, this is a segue for us to go into the next piece of this lecture, which we're gonna cover the topic of how to define and call a function, UDF. We've already seen that, in my attempt to talk about functions versus method. We defined a couple of functions already, but this particular module will just again show us how to define and to call a function within Python. So user-defined functions, because we're defining these functions ourselves. That's why it's called user-defined function. Now, there are functions that come out of the box within Python. All right, so for example, print is a function, but we're not defining that, right? Because Python has already implemented that for us. But if you have to define your own function, that becomes a UDF. So let's see an example. So how about we make a function that prints hello world? All right, so how do we go about that? So we say a simple way would be def. All right, very basic function, hello. Remember, we simply just have brackets here, open, close, and end it with a colon here. Now, what do we want? We want to print hello world. All right, and that's what our function be, and then we can simply go ahead and return out of that function, right? If you notice, the functions usually end with that return statement. So this is my function, very basic. Call this function, it should print us hello world. And how do I call the function? Again, I go back one line down. You have to be careful with the indentation. I've seen people making the mistakes of coming here and then saying hello, trying to call that function like this. All right, when you do something like that, it really is a recipe for issues for you, right? But the way we're actually going to call the function is to make sure that we'll go one line in this way, so we're not still part of that function definition. Because what happens is it considers this as one block, one piece of code, but then it returns here and the function is never called, and it never sees this piece of code to call it. So but once we have it like this, what happens is it defines a function, it returns, and then it sees this hello, then it actually calls it. So very, very important. If you're running a function and you're having issues, just make sure that if you're writing a function and having issues or not seeing what you expect, make sure that your indentations are correct. Now, to call the function, we simply just call the function like hello and then the parenthesis, nothing more. We're not putting any colon here, we're not doing anything like that. So this calls the function and executes whatever we have inside that function for us. So if you run this, now you see it prints on the screen hello world. That's how we define a user-defined function in Python and call it. Now, we might even make this function a little bit more interesting by passing it our values, right? So we can go ahead and ask for a parameter in this function. So the way we ask for a parameter in a function is to say name. Let's say name. All right, let's maybe just say my name. So now I'm saying def hello my name here. So this is now a parameter. All right, and I'm going now to print hello instead of hello world. I'll print hello my name. Hello my name is, okay, and then my name. I'm passing now my name. All right, we've seen how to do string concatenation in previous videos. So here is a function hello. Now we'll have a parameter in here called my name. Now I'm printing hello my name is, then I'm printing out my name. Very basic function. Now if we run this function, let's call this function so hello. Here I've asked for a parameter. Now we need to set a specific value, so it sends that to the parameter and actually prints that to the screen. All right, so this is what we need to do. So let's see if we try to run this without that. You see it complains because it's saying I've defined this function with expecting a parameter here, but I haven't passed any value for this parameter to go ahead and print. That's why it's failing here, and it's saying missing one required positional argument, my name. All right, so we have to specify a value in here. So let's say Fru. All right, so this value, again, remember we're calling this specific value now an argument. So I'm calling hello, and the argument I'm passing is Fru. So an argument is a specific instance of a parameter, right? So just really have that parameter. This is a placeholder. Argument is the actual value that you pass. So now when I say hello Fru and I'm passing this argument, it takes this Fru and it sends it to this function, and then once it goes in here, it prints hello, my name is, because now I've passed in Fru here, it's gonna print hello, my name is Fru. All right, so you go ahead and run that. We can see hello, my name is Fru. All right, so starting from calling this function, and remember the definition of the function has to be above before calling the function. I can't do something like this, right? It'll be a problem because it's saying hello Fru, but it hasn't seen the definition of a function yet. It doesn't exist within Python because Python is procedural. It reads from above and comes below. So it's trying to print hello Fru here, but this has not been defined. So if you're trying to call the function, that definition of the function always has to be above you calling that function. So we have to define that function, and then this is where I go ahead and I can call that function within Python. So again, guys, very powerful. There are several ways that we can go ahead and call function, but I really want to urge you guys to play with it. Write your own function that can add two numbers, subtract numbers, divide numbers. Again, very powerful. Now this is a segue into something that we've talked about already, which is gonna be a 6.1.2. and in 6.1.2 we're gonna really specifically talk about the difference between parameters versus argument. So parameters versus argument. Now again, I've talked about this quite a bit. Let me bring up a definition to the screen, where a parameter is let me copy one of the functions that I had here just so we can talk through parameters versus argument. Very important concept. A parameter is the placeholder, and the argument is a specific value that's passed. That's basically what it is. The placeholder, once you define in a function, whether it's a function or it's a method, a function within the class, that parameter is, this placeholder is a parameter. Now once you're passing in specific values to replace the in place of your parameters, those specific values are called arguments. So if anyone ever asks you a parameter versus an argument, guys, this should be a slam dunk answer for you to give. In interviews, very often people are asking questions like this: what's a parameter versus an argument? And it's supposed to be so basic that if you don't understand it or you can't explain it, the interviewer might be looking at you and feeling that you don't really know what is going on. So it's very important to master this concept. Now this will take us into the next piece of this lecture, where we'll dive a little bit more into, let me actually print out the definitions that I got here on the screen. Just so these are the format definitions that I got across reading on the screen. All right, and then let's format this. So here it says, I hope we can see all this. It says parameters are the names used when defining a function or a method into which arguments will be mapped. In other words, arguments are the things which are supplied to any function or method call, while the function or method code refers to the arguments by their parameter names. All right, might be a little bit confusing there, but a function arguments, you can call a function by using the following types of arguments, which we're gonna see in a little bit. So basically, this first statement, a parameter is simply the words or the definitions used in the function when defining that function, and an argument is passed. Now let's go into the next piece of this lecture, where we are going to see how the different ways we can call functions. We've seen some of them already. All right, so once we define functions, there are several ways in which we can pass arguments to a function, and we can see required arguments. Some of them will be required, some of them will be keywords, some of them will be default, and some of them will have variable length. So there are several ways to pass arguments to a function, and it's important to know the different ways. That way, if you're writing your code and you're trying to implement a particular function, you can use those ways as much as you want. All right, so the very first way that we're gonna see is 631 is 6 module 6 lecture 1 concept number 3. So that's about default arguments. So default arguments, we've already seen an example of a default argument. So for example, we can say let's call an example of plus. So we've been doing a function, so let's define a simple function here called plus. All right, and we're gonna say a b. That's gonna be our two parameters, and as usual we're gonna return a plus b. And now let's print on the screen. Actually, let's not just print that way. Let's say x equals plus 3 comma 5. All right, and then we go ahead and print x. We've seen this already. We've seen how simple it is to define a function like this, and we get our results. No problem. Absolutely no issues doing this. Now, what we want to do here is, this doesn't talk about default arguments, right? Because we're defining two parameters here and we're simply passing that value. Now, what if I wanted to say plus 8? Let's say I wanted to define a function like this. Or let's actually make it plus 8. All right, where this function, you give it any number and it's gonna add 8 to that number. All right, so what we can do is to make one of these parameters a default parameter for us. And the way we do that is we can simply set equals to 8. So every time we call this function, by default, b would be 8. So if I give 5, it's gonna do 5 with 8, right? So here now I can simply just call this function as a equals 3. All right, and then this will be plus 8. So I can simply call my plus 8 function and give it just one argument, a equals 3, because I've set a default argument here as 8. All right, now and this is powerful. If I just do this, all right, and let's go ahead and run that, you see it still gives me 11. All right, because it takes its first argument as 3, which comes in here, and then b, it knows that b is 8, and then it says 3 plus 8, and that's why we're getting 11 on the screen. If you really want to make your code readable, you know, sometimes we'll do something like this to really specify that this 3 is for a, and then you don't need to set anything for b, because by default b would be 8. If I did not specify the default value for b as such, and I run this, we got a problem. All right, because there's no default argument that has been set on my method definition or my function definition. So we have to ensure that we have to set that default value in my function definition. All right, guys. So very, very, very important concept within Python if you're trying to set default values. Now, even though I set the default value here as 8, we can still override that default value if we really wanted to. All right, let's say, all right, some point we want to do plus 8, but maybe not really with 8, right? We can say b equals to 2 as an example. So the arguments that are passed here will always override the default parameters that are set in the definition. So even though I've said b equals 8, if I call the function this way, it's going to take a equals 3, b equals 2, and it's going to override that. All right, so if you think about the precedence or the predicates, this has a higher level over this. So whatever you do here is going to override whatever we have over there in the definition. So just something to have at the back of your mind. Okay, and I like this because sometimes maybe you have a plus 8 function, but in some unique circumstance you really don't want to do 8, you want to do something different, then you can just simply override the arguments or the arguments, and that would, you know, ricochet down into the function itself. So very, very, very important. Now, This takes us into the next piece of the concept, which would be the ideal required argument. So what we've seen earlier was just default arguments, so arguments by default, right, where we can set the default arguments. But what if we want a required argument? This is basically what we've been seeing before. Very simple. We have a simple function definition, say plus, right, and we have a comma b. This is required, right? And if we return, if we go ahead and return a plus b, all right, and we say x equals to plus 3 comma 5, and we print and we go ahead and we can print x. So if I run this, we get 8 on our screen. All right, this particular parameters here are required. These are required, and these arguments, you have to specify these arguments for these parameters. None of them is a default. If I had equals to here, equals to say 5, yeah, then that would be a default argument, but we don't have that, right? So in this case, we have to pass all the specific arguments that are expected within this function. If I try to run this code without one, it's going to fail. It's going to fail. All right, if I remove all of them, I try to run it, of course it is going to fail, and it says missing 2 required positional arguments. So it's very important to see this. If your code is failing and you're calling a particular function that you've defined, a user-defined function, guys, just pay attention. Maybe there's something wrong with the parameters that you're passing within that function. And to be honest, Python makes it even easy, because Python is not strongly typed. For things like Java, right, you might still pass the same argument, but if the type of it is wrong, you get errors, right? So that even makes it very, very tricky to handle with. I feel Python, since it's not very strongly typed, is a little bit easier to handle. All right, so this is an example of required arguments, and we're gonna look at the next type of argument that we can pass, and this would be keyword argument. So keywords argument, what does that look like? Again, just bear with me for doing the function definition over and over. As a matter of fact, we can just have that function definition, since it's the same way what we're doing. So we're gonna define the plus function here, right? It takes a and b and return a plus b. Now we can go ahead and say x equals to, of course we're gonna do a plus a and b, and then we can print x on the screen. Very, very simple, very basic. Actually 3 and 5. All right, so we can go ahead and print x on the screen. Very simple, very basic. We've seen this quite a bit of times. Let me move this, zoom in well. So if I go ahead and I can run this, we get 8. Now, but this is just the basic function definition that we've seen. What is the keyword argument here? That's important for us to pay attention to. Once we saw earlier, we can say a equals 3 and b equals 5, and then we can run this. All right, so this is a keyword argument, because we're specifying the specific name of the parameters in the argument. So we're saying this 3 should be set for a, and this 5 should be set for b, and that's what we call a keyword argument, right? If we say this was name, let's just say this was age, for example, and then we wanted to return name plus age. It doesn't really make sense what I'm doing now, but I just wanted to get away from a and b just so we see. All right, we can come in and say name equals 3 and age equals that, and specifically specify that kind of sounds funny, but so we can do something like this and it runs perfectly fine. Now you might say, but Fru, that's trivial, that's just like calling it. Why do I have to spend all the time writing out the name of the parameters in my argument if it just does the same thing, right? Here's where it gets interesting, because you can now switch something. You can do something like this which you couldn't do before, right? You can now say something like you can call the function like this, which you couldn't do before. All right, and it's going to run just fine. Okay, so once you specify the name and the age, I think this addition doesn't really give us the gist of what's going on here, just because we're adding the two numbers, and whether you add 5 and 3 or you add 3 and 5 is going to all be the same. I'm sure some of you might be saying that, but guys, if you're doing something that is not necessarily let's say a plus b equals b plus a, this is where those things will come into play, right? But you have that ability to specify the order of the parameters that you want to call if you actually specify the name of those parameters. All right, so very important to see. Let's actually say let me see if I can make a change. I really want to make this concept here hit home. So let's say first name, let's make sure we last name, and then let's do Louis in there, and then we have so we're gonna have to change this one, first name, last name. Let me just make some changes here so that this hits home. First name, last name. All right, so we want to do last name and last name. All right, so we can go ahead and run this. I'm gonna put spaces in here just because I know what will happen. All right, so we can go ahead and run this. So first name through last name and day. But what if I switch my last name this way? What do you think will happen? All right, what do we think will happen? Again, I'm saying I'm starting my function last name Louis, first name Fru, but guess what happens? Because I'm specifying the position, you would think that this would send that into first name, but not necessarily. All right, I still get my result of Fru Louis. So because we're specifying the specific names of that argument, then we avoid any issues of confusion in our parameters. I hope this makes sense for us. Now let's move on to the next type of way of passing arguments, which is called variable number of arguments. So instead of specifying just one argument, two arguments, three arguments, how can we just specify an unlimited number of arguments to a function and then have the function do something with it? So in this case, we're going to define a new function here called limitless plus, for example. All right, and this function would take a certain kind of argument. Now in this case, we'll make it an unlimited argument, and the syntax for that is you do the star, right, and then we can just simply give it the argument name. All right, and now in this case, we're gonna return on the screen. We want to do something with those arguments. We're gonna return sum, all right, of the args that we get, of the arguments that we get. So that's basically our function definition. Now we can go ahead and say x equals to limitless plus, and we can do 2, 9, 1, for example. All right, we can specify any number of arguments that we want in here, and if I go ahead and I print x, guess what happens? It adds all of that and it gives us a result of 12 on the screen. All right, so I can still go ahead and make that as much as we want. All right, and we get the good old 24. All right, so it doesn't matter the number of arguments that we pass in here, the function now can handle that. All right, so this is what we call a variable number of arguments. I can put as many numbers in here as I want, and it's going to give us a result. What happens if we try something like this? All right, now it complains because even though I'm taking a variable number of arguments, I'm doing a summation here, and summation expects numbers, right, doubles or ints or floats, but not a string, which I'm trying to do here, and that's why we get a failure. But you can put an unlimited amount of numbers in here limitless, and it's gonna do the addition for us. So this is a variable number of arguments within Python. Now the next one that we're gonna see would be global versus local variables. So the next concept within this module and lecture, so this is module 6, lecture 1, concept number 7. It's going to talk about global versus local variables. So what is the difference between a global and a local variable? So let's try that and see with some examples of a global versus local variable. So in this case, we'll define a value. Let's define a value and call it init. All right, let's just define the value, call that value init. All right, and that's just a simple value that we have on the screen. Now we should define a function here, and that function will be plus. All right, we already know how to do that, a plus b, and what we're gonna do is return a plus b. Very, very simple. Okay, now the next thing that we want to do is to go ahead and test for different let's actually make total here equals let's just make this a little bit more cleaner to read. So let's set total here equals a plus b, and then we'll go ahead and we return total, so it's just the same as that value. All right, and now what we can do here is to go and say, okay, print to see the difference of the values that are coming through. So if I go ahead and I print this is outside the function, and I'll make the same copy, and I'll print this is inside the function. All right, but what is inside the function, what's outside the function? This will be total. Plus 3, 5. All right, and then this will be total. Let's actually change that from init to total. All right, so let's take a moment and understand what we're doing here. The idea for this is to understand the difference between global versus local variables. So what we've done here is simply to set a variable here outside of a function. All right, so that variable total is set to 1. Now we'll define a function, and we're saying in that function total equals a plus b, and we're returning total. So somewhere within this function we're changing the value of total to set to something else. Now in the print statement, all right, so when I print 3 plus 5, right, what happens is it goes into the function, it sets total is changed, and it returns total. So this total that we're printing, actually this should be changed. So this will be outside, this should be inside. So this total inside the function is changed. All right, but then if I still print my total outside the function, it should still be left the same. So let's go ahead and run this. While we're doing, we gotta convert all of this to string if we're gonna print them on the screen. All right, so now that those are all converted to strings, let's go ahead and check. All right, so there you have it. So inside the function we get 8, right? So inside this function, because we're calling the function here plus, and we're sending in our 2 values, it comes in here, it sets total, and we get 8 being set to total, and that's what we're printing on the screen here for that return result. But outside the function, so outside meaning this, we're printing total, but this total coming here is 1, because this one outside the function hasn't been changed. We haven't called the function here. All right, so that's the idea between global versus local. So local is changing in here within this function, but it doesn't affect what was set out globally here. All right, and this will be very, very powerful, especially once we start talking about classes and the specific attributes for that class and how we can access them or not access them. So just bear with this idea of global versus local. Global is outside, local is inside. If you do anything local in this function, it doesn't affect this global variable that has been set out there. All right, even though we're setting total equals to a plus b at some point, we're calling this function, but at the end, once we still print total, it hasn't been affected because the function cannot change the value of a global variable. It can use the value of a global variable, but it cannot change the value of a global variable. So just something to have in mind in terms of scope within Python or programming in general. Now, the next piece that we're gonna go ahead and see would be talking about functions passed by reference and passed by value, and understanding that within programming. So what does it mean passed by reference and passed by values? So the way we're gonna do this is we're gonna use a data structure of a list, which we saw in one of the previous modules. I believe that was module 3, where we talked about data structures. So we should define a very simple function here, and then we'll call it change me. All right, and change me is gonna take my list as the parameter. All right, so let's go ahead and actually change that list. So we're gonna take my list dot append. We're gonna append some things to that list. Whatever list we get, we're gonna append some more things to it, right? So we're gonna append 3 and 4 to that list. All right, and then let's go ahead and return out of that. We can print the list, and then we can just simply return out of that. So now let's actually call this function that says change me. So what can we do? We need to set my list first, right? We need to set a new my list equals to, so this is my original list, and let's make it 8, say 9, 10. So this is the list. Now we need to change my list. So let's go ahead and change me. So we're gonna call that function change me, and then we're gonna pass it my list. So we simply define a list. Now we're gonna try to change that list by calling this function. And so once we call the function, we're passing this list to it, 8, 9, 10. So what we want to do is gonna take 8, 9, 10 coming in here, and then it's gonna append 3 and 4 to it, and that's what we're doing. Okay, and now if I go ahead and print my list outside, okay, and then we can go ahead and print my list. All right, so this will print my list outside. But for this to really make sense, let's also print the list inside. So let's also print the list inside, and the way we do that, we should also print let's go ahead and print let me just say let's go ahead and print this guy. I'm gonna say x equals to my list dot append. Let's go ahead and print my list inside. All right, I hope we're following this along, and then we're gonna print x. So just bear with me for using x in there. All right, so let's think about this and just do a quick recap before we run this. We're looking at pass by reference and pass by value. That's the main discussion for this particular concept. We've defined a function. It takes my list as the parameter is my list. It's gonna take my list, is gonna append some values to that list, and then we're simply gonna print that list to the screen, and then we return. Now to actually call this function, we've defined our list, which is gonna be an argument, and we're simply sending that to change me so that it can be changed. All right, and then we're going ahead and we're printing that. So if we run this, all right, we can always simply change that to string. Not a problem. Not a problem changing something from a non-type to a string. We can do that very easily by now. So there you have it. Okay, So let's go ahead and run this again one more time. And what do we see? Outside we see my list outside, which is here. It's we're converting that to string. We're seeing we have our original list that we provided, and we've appended 3 and 4 to it. But if you notice inside the function, even though I'm printing my list inside and I'm saying string, the result is none. All right, and this goes into that idea of pass by reference versus pass by value. When we're working with something like lists and such, we're not actually taking this list and sending it into this function and being able to do the appending there. It's simply a reference to this list. So this function is simply going to the original list and adding a reference to it, but that list is not available within this particular function. So and to really see what I'm referring to, if you go ahead and print my list, let's do string on my list. All right, so if you go ahead and do something like that, you see we are actually printing this value 8, 9, 10 here, but once we're doing append is simply adding to a reference of that string. It's not actually changing this value, it's changing this value, and it's only appending to it. So there's just one instance of that string that's available. All right, so this is something that can be very nuanced and a little bit confusing in Python. What do we mean reference? What do we mean values? And what functions work by reference and what functions work by values? Guys, this is something that it's especially with strings, will actually appending to the reference of that string, not the actual value of that string. And that's why if we come in here and we're printing string, we're getting a none, because the modification, this appending, has actually appended to the original string, which is what we're printing here, and that original string is simply the reference to it. All right, it's not actually printing to the actual value. So something very interesting and a very interesting concept to pay attention to. Now the next piece that we're gonna see, the next concept would be return statements. So we've already seen a bunch of return statements, but never really took the time to explain why we write return. So this particular piece of it would explain for us the power of the return statement and why we actually use that. So to do that, let's define a new function. As always, we're going to define a function plus, and that function takes it's going to take 2 arguments, a, b, and as always it's going to just simply return for us let's actually do total equals to a plus b, and we're gonna return, right, return, because this is what we're talking about in this particular concept. We're gonna return total. All right, and why are we doing that? Why are we returning total? So that said, let's actually call this function and see. So let's do x equals to plus 3, 5. All right, and then we want to print x. If I go ahead and I run this, so of course it prints my x as 8, and we can see 8 on the screen. But why do I have to include this return statement here? All right, it's because what is happening here is, let's just comment this out for a second and see what happens. If I run this, right, it says none. Okay, because I'm saying plus 3 plus 5, and it comes into my function and it takes 3 and 5 and it says total equals to 3 plus 5, but then nothing happens, right? It doesn't give me back the result for me to set into this particular variable. All right, and that's why we need a return statement for me to then get back the result. So if a function doesn't have a return statement and you call the function, nothing is going to come back from that function. So at the end of every function, after you've done everything, all right, we end with the return of what we want on the screen. If instead I said return 6, all right, the function will just return 6 to me. It doesn't matter whatever I put. I could put 1000 in here, it's always just going to return 6 to me. So return, you return the last thing that you want for that function to send to you, and I always want the function to return for me the addition of a and b. All right, and that's why I get that value, which is the addition of A and B, in this case 100 plus 5, which is 105, and that's what we mean by a return statement. All right, so if I came in here and I print and this could be confusing sometimes too, and I print total, all right, and I run this, we're gonna see 105 two times. So what happens is the function comes in here, it sets total, it's gonna go ahead and print total, which is 105, but printing is not returning, right? If I commented this out, I will still see 105 on the screen, all right, printed out, and this is the printing. But again, you see in this next print below where I'm actually calling the function is none, right? Even though I've printed this on the screen, I'm not actually returning any value back. And imagine if you wanted to do something with the value that you got back from it, post calling your function, everything below that would break. So printing on the screen within a function doesn't mean you're returning. To return a value back to the original call, all right, we actually have to set this return, this particular return a word within the last line of the function. If I return here, all right, what do we think will happen if I come ahead and I return here, right? I will never ever get this print happen, because once it returns, all right, this everything after that in that function is useless. It doesn't work, right? You can as well just treat this as comment, because it's never gonna print total or anything. If I'm printing 5, just to see that I'm not making this up, if I print 55, it's never gonna print 55, because once it's gone in that function and it hits return, it exits that function and then it returns whatever it has or whatever you specify in there for you to use. So if I'm calling that function, it returns the value for me to use to X, and that's why we have it this way. So return is something very, very powerful within concept. Now guys, let me take a sip here. All right, so we're gonna go into the next piece, and this is something that really could be challenging to some people, but guys, believe it or not, it's coming very more and more popular, and that's lambda functions or anonymous functions within Python. If this is a little bit of confusing concept to you guys, just play with it more and more. I always tell people the more you play with it, the easier it becomes, right? So that said, and with that preface to this, we're gonna look at some examples of what is a lambda function and how can you go ahead creating lambda functions, right? So we saw how we define function as def plus, say AB, all right, and then we can simply return A plus B, something like that. That was a traditional way of defining functions, but with lambda functions or anonymous functions, it doesn't work that way. The syntax is a little bit different. So let's say we want to add or double a number, all right. How do we go ahead and do that? So in anonymous functions, we can simply say double, all right, and the syntax for that is lambda. And what do we want to double? We're going to double a value, which is our parameter. So remember, parameters is x, all right. So once we take x, now we need to do something with x, right? We need to double x. So to double x is simply as saying x, right, times 2. So that's simply doubling that value, and that's it, all right. And now we can print double 5 as an example on the screen, and we should get a good old 10. So this, in short, is a lambda function. So the first time people see this, it could be a little bit confusing to kind of read, because we're kind of used to the traditional way of functions. But lambda function is just simply an inline function. It has to be one line. We cannot do this, something like this in a lambda function, try to make them different lines. That's not going to work. So everything that lambda function is really one line, and it always starts with maybe some scenarios where I'm going to show will be a little bit different, but lambda, and then you specify your inputs, all right, and then you specify what you want to do with those inputs, and then it takes that and then it returns that to this value. So if I say double 5, then it returns, let me just say result, just so that we don't get it confused, equals to double 5, and I'm printing our result here. All right, so basically this is what we get. Now if I choose to say 10, guess what happens? Errors, because my lambda is expecting just one value, so everything before this column here is what is my parameter. But now I'm calling the function, so this is a lambda function, so this is not a variable anymore, this is a function actually. All right, it's anonymous, right? So I don't know why they really call it that way, believe it or not. I'm not quite sure why. Maybe it's anonymous because I don't know for now, but this is just a lambda function. And I can then call that function double and pass in my parameters. Here, if I'm passing in 2 parameters, it doesn't like that because my function is expecting 1 parameter, and we should get 30. All right, so this is the lambda function. Let's see some more examples of lambda functions. Maybe we want to make this lambda function too similar to the way we did the plus, all right, function. So let's make a lambda function called plus, and again syntax is plus is lambda, and then we want our parameters here, x and y. So these are 2 parameters, all right, and we want to return x plus y. All right, so we're simply going to return x plus y. And so if I come in here and I do plus 15 and 5, for example, so it's gonna take, so we're calling the lambda function up and passing 15 to x, 5 to y. So it's gonna add 15 plus that, return it to this value, and that's what we're printing on the screen. All right, so plus 15 and 5, it seems to be giving us a result, and the question is, why are we getting a result? We're saying missing because my syntax here is wrong. All right, so it should be 15 comma 5 because I'm specifying the 2 values, not actually adding them. And if I run that, it gives us 20. So guys, so there you have it. This is an example of a lambda function. And while at this, let me just explain what this lambda function is doing. If we were to write this as a traditional function, so we're saying lambda x y, and then we're returning x plus y, and then we're calling it. This is exactly the same as if we went down and said def plus, all right, and we're taking x comma y, and then we're returning x plus y. All right, and then we go ahead and call x. So this is the same as this one line of lambda function, and you can begin to see why this is becoming, some people kind of like to do this for you wouldn't do very complex things, I would say, within lambda functions, but there are certain specific kind of tasks that lambda function just makes way more sense than others, especially for iterative kind of tasks, for tasks where you kind of have to go through like a list of things, right? Because lambda function can apply that across the entire list. Now, if that doesn't make sense to you, let's actually look at an example of where a lambda function is being applied to a list. All right, now I have, for the sake of time, I have that pre-built already, so I'm just gonna paste that code to the screen and then just walk through the code. So for us to do this, we're gonna import a specific library to see how lambda functions can work within lists. So we're gonna import the library. So from function tools, we're gonna import reduce. Now we set the list here, a very simple list, 1 to 10 within to this variable, and then now we have this lambda function, and this lambda function is going to, because we saw how lambda functions work before, let's just read this the way it's written. So lambda x is going to take a value x, all right, and then that x in our case would be a list. We're going to send a list to this lambda function. So whenever we call this lambda function list, right, it expects an input parameter which is going to be x, and this is how we read lambda functions. So it's going to be x. Now we're doing something to that x, that list, once we get. Now what we're doing here is we're going to check for every value within x, right? We're going to take it and multiply by 2, and multiply that value by 2 and check, is it greater than 10? So 1 times 2, is it greater than 10? So this would result in a boolean because we're doing a conditional check here. All right, now and then based on that, if it's true, we're gonna put the result in so this is our input, which is x, and this is my list, so we're passing here, and it's gonna take that result and it's gonna filter that result out. So we're filtering the result out. So, and it's gonna filter if this condition is not true, right? If it's true, then it's part of it. If it's not true, then it's in. So let's go ahead and actually call this function. I think once we call the function, that would make a lot of sense. So let me just comment this out. Lambda functions are very, very powerful, guys, especially in data science, where you have to work with lists, map reduce, and things like that. Lambda functions are really powerful for that. So let's run this and I'll explain what has just happened here, as we already started explaining. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's our list. All right. Now we've simply defined our lambda function x, which is taking one up input, and that's why we're printing out. So here we're gonna print filter list, which is our result. So lambda is taking an input x, and we're passing that x as my list. So this my list is coming into x here. All right. So this is how we're sending my my list into x. Now what we're doing is going in and saying filter the values if x times 2 is greater than 10. So this is what we want. We want to keep any value where you take that value times 2 is greater than 10, and we're going through this list and we're applying this. 2 times 1 times 2 greater than 10, nope. 2 times 2 greater than 10, nope. 3 times 2 all the way to 5 times 2 greater than 10, nope. Right? 6 times 2, is it greater than 10? Yes. Now we'll take this that and we're putting it in this list. So we're gonna return a new list. So, and that's why our new list is gonna have 6, 7, 8, 9, 10. All right, because those meet this boolean condition here. The first time I came across lambda functions, it really did not kind of make sense, right? And I'm sure we're following along. It's maybe not making sense, guys, but it's a very, very powerful concept. If we had to do this with a for loop, we'll have to write a for loop that will iterate through that list. So for each value in x, if x is greater than 2, it will just be a very time consuming thing to do, but you can do that very, very quickly with a lambda function. All right, so a very, very powerful concept. Let's look at a different lambda function here, very similar to what we've seen in here, and this one would be using maps, map function. So, and then we're gonna go ahead and print the map on the screen. All right, so I'll try again to explain this, guys. Just spend some time and follow along as we're doing it. You might have to rewatch the video over and over to really get it. So lambda is what we usually start with. Is taking an input, which is x. All right, and that x was sending my list. So we're sending the list that we've defined up there. All right, and then we're saying x times 2. We're simply just doing x times 2. So in here, we're not doing a boolean. We're simply taking x times 2 and mapping that into a list. So the result is we're gonna iterate through this and then multiply everything by 2. So if I run this, we should see 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, that's what we should be getting into our new list. And that's what this lambda function is doing for us. All right, so if I give you a list and say multiply this list by itself, guys, if you had to do that manually by hand, it could be very, very, very time consuming for you to do, or you have to use a lot of if conditions or while conditions. Guys, lambda functions allows us to do it very, very quickly. Now we've introduced concepts like maps and filters. If this doesn't make sense, I'll just encourage you to just spend a little bit of time to read up on them. Right, map really came from the idea of map reduce, and since we're talking about map, we could as well talk about the reduce function, which is what I had commented out here. So similar to the reduce function, instead of just mapping out the result, what this is going to do is going to sum the result into one value. So reduce list would be again lambda, right? And then so lambda xy, and what it's going to do, it is going to simply add the two values together and return that. So this simply takes these values and says, okay, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, and that's what. So it's just simply going through and adding that, and then 5 plus 6, actually 15 plus 6, 21, 21 plus 7, 28, 28 plus 8, 30, 28 plus 8, 30 what? 36, you know, for the, yeah, just simply add that, and I think it should be about 55, I believe. Let's print out reduce. So let's see what reduce is gonna give us. So we print out, yep, 55. So there we have it, so 55. And so reduce, again, is another function available within Lambda functions. It simply takes all the values within a list that you provide, and it kind of it applies the functions to it in a reducing faction, and it came from the background of map reduce. All right, so we're reducing the list. So guys, there you have it. I would encourage you to play around with these examples and really get your head around what's going on. This is the simplest that you can understand, or the map, but once you have a handle on it, guys, this will be a very powerful tool to have in your arsenal as a programmer. If somebody gives you a list of things and say apply this function to every items in that list, you can just simply map it and be able to transform every function or every item in that list without having to use a for loop. All right, now this takes us into the next piece. This will be a very short concept, but something nonetheless worth mentioning is pass. Right, we can define a function plus, and that function takes a, b, and within that function a, b, we just simply pass, right? And if I say print plus 3, 5, nothing happens, right? Pass is if you are defining a function, that should be a comma. So you use pass if you're defining a function but you don't want to implement anything in there yet. So if you just want to have a placeholder, sometimes as a programmer you might be writing and you might want to say plus 1, and then you want to also define a new function, right, and call it plus 2 as an example, but you're not ready yet to implement plus 2. All right, so maybe you want to define a function called plus 1, and you want to define another function called plus 2, and you're just not ready yet to implement them. All right, so what you can do is just simply pass, and that would just make your code not fail. That will simply make your code not fail, and then you can come around and implement what you need there. So pass is simply saying, all right, nothing, we're not going to do anything here, just go ahead and pass. All right, so that's simply if you don't want to implement anything within a function. And then last but not least, a very, very powerful concept within programming and Python, but programming in general, and that's the idea or the concept of recursion. All right, the first time I saw recursions, guys, I would be honest that it actually blew my mind. I kind of had to sit down and kind of like spend some time to really understand what was going on. So, but that's what we're going to be looking at in today's in this particular concept. So recursion is simply the idea of calling a function to itself. All right, so you want to call a function to itself, you're simply doing recursion, right? So let's actually define a function to see what recursion actually looks like. So let's call it demo recursion. All right, so it's like simply repeating, but we're gonna take a value of x. Okay, and then what we're gonna do here, we're gonna check, okay, if we're gonna check if x greater than 0. All right, we're gonna do something. We're gonna return we're gonna return x plus, we're gonna return the result. Actually, let's not return the result. Let's just set the result first. We're gonna set the result equals to x, right? So we're gonna take x. So if you start with any number and that number is still greater than 0, we're gonna take the number and then add it to itself minus 1. All right, so we're gonna add it to demo recursion of x minus 1. All right, and we're gonna print. We can now go ahead and print result. Else, if the number is not greater than 0, we'll set result equals to 0. All right, and then at the end we return results. So either way, we're gonna return result. Now, if you go ahead and let me just print something out here on the screen, and then I'll explain what's going on now within that function. So if you go ahead and print recursion demo, all right, and for that we're going to do demo recursion, and let's give it say 10. All right, so if you run this, let's see what's happening here. All right, so we have 1, 3, 6, 10, 15, 20, 21, 22. So that's what's happening. So what's going on here, guys? Let's see what's going on. This is simply taking the summation. Let's do recursion 5. I think 5 will be very easy. Or 3. Let's do 3 first. I think I'll build up to 3, and then so we can see what's going on till the end. All right, so we know that we're calling recursion on 3. So let me actually explain it here. So we're starting here. We have 3, 2, 1 if we're counting that, and then of course we have 0. So those are the things that we have to 0. So we start with 3. All right, we're calling a recursion to 3. So recursion is basically calling a function within a function. So, and there are reasons why you do that. I'm sure you're asking, why do we do that? But let's see why and how we do it. So we start 3, right, and say if 3 greater than 0, then we're in this block. So of course, it's 3 greater than 0. Yes, 3 is greater than 0. So we come in this block. Now we said result equals 3 plus, right, 3 plus 1. So at this point we have 3. Oops, bear with me here. We have 3. All right, I'm right here, and I'm saying 3. Let me actually do it up here. We're saying 3 plus, we're doing 3 plus 1, and so we have 2 here, and we're calling recursion on 2. All right, and then we're calling recursion on 2. So we're doing recursion on 2. Okay, so now we have 3 plus recursion on 2. But guess what? So since we're calling recursion on 2, we're calling this function again on itself. All right, so now we have 2. We're starting here, and we have 2. Okay, and what we'll have is so we've printed out the 3. Okay, so what we have now here is 2, since we're calling the recursion on itself. So it's gonna be 2 plus, it's gonna come in here and say, is 2 greater than 0? Yes. So result is equals to 2, right? So 2, which is our x now, plus recursion on 1. All right, so just think about what's happening here. You know, there's this movie called Inception. When I watched that movie, at one point I was just like, this is just pure recursion in action. If you haven't watched that movie, guys, it was a very one of my favorite movies of all time, and it kind of like, it's a dream within a dream within a dream, like 6 layers in, and I'm like, there you have it. That's that's a recursion. All right, almost similar to what we're doing here, but just bear with me to explain this. So now we are at value 2, so we're going 2 plus recursion. All right, and then we say 2 minus 1, so we have 2 minus 1 here would be 1. But guess what? We're calling recursion on 1, so we're continuing here. We're having 1 plus, so we're going in here. All right, so now we're doing recursion on 1, So is 1 greater than 0? Yes. So we're coming in here now and we're saying 1 plus recursion on 0. All right, so we're doing recursion on 0. All right, and then now we're doing it again on itself. And so we say 0 plus recursion on, guess what, 0 minus 1 is what? Minus 1. Okay, so then we're coming in here. So recursion on 0 is equals to 0 plus recursion on 0 minus 1, which is minus 1. But guess what? We're coming now to call recursion on 0, right? But at the point of calling recursion of 0, this is not even gonna work, because we're gonna say 0 if 0 is 0 greater than 0. Nope. So 0 greater than 0 did not work. All right, so this is where the recursion ends. So at this point, we're gonna say 1 plus recursion of 0. Well, it's gonna say recursion of 0 is 0 greater than 0. Nope. Else return else result equals 0. All right, return return result. All right, so it's gonna return a result. What would that result be? 0. Okay, so it's gonna return a result to 0. So now guess what? We know the recursion of 0 is 0. So what do we have here? What does this line evaluate to? It evaluates to, if this is same as saying 1. Let me actually make it this way. This is actually as saying 1 plus 0. And what's 1 plus 0? 1 plus 0 is 1. So we're coming in here now. So just think about, we're going back up now and kind of like evaluating our recursion. So we're coming up here now. We knew when we were at 1 plus recursion of 0, that gave us same as 1 plus 0, and it prints out that result, which printed out 1. Right, so it prints out 1 here. But guess what? Now we'll have to go by 1 level up and actually fill this value. So recursion of 1, so this is recursion of 1, give us 1. Now to evaluate recursion of 2 is going to be, 2 plus 1, which was the result of recursion of this level, and that gives us 3. All right, so that's where we're having this 3 coming from. And then we go by 1 level up. All right, and that would be 3 plus the recursion of what we had before, which would be 3. Bear with me here to type. Well, 3. Oops, why does it keep going down? 3. So it'll be 3 plus the recursion of whatever we got from here. But guess what? Recursion of 2 plus that was recursion of that plus 3, which gave us 6. All right, and that's how we have our 6 here. All right, so that's basically recursion. I hope this kind of makes sense, right? I said the first time I saw recursion, it kind of took me a while to understand, like, a function calling itself and why is that relevant, guys. This is a simple example that we've seen how that works. All right, we started with passing a recursion of 3, and it comes in here, right, and it says is 3 greater than 0. Nope. Now we're going, well, it's 3 greater than 0, yes. So we're coming in here and saying 3 plus recursion of 2, right? And so this is why we had 3 plus recursion of 2, but we don't yet know what recursion of 2 is. All right, so we need to go evaluate recursion of 2, right? So now we're evaluating recursion of 2 here. All right, so we just keep a placeholder here, and we're going to evaluate recursion of 2. Now we've evaluated recursion of 2, which is going to be 2 plus recursion of 1, and then we have to go evaluate recursion of 1, which would be 1 plus recursion of 0. Then we go evaluate recursion of 0, and we saw that 0 is not greater than 0. So, and in that case, the result is 0. So we're gonna take recursion of 0 will give us 0. So now we can evaluate this. So since recursion of 0 is 0, we know it's 1 plus 0. So here we have 1. All right, and so recursion of 1 is gonna be 1. Now we have the value of recursion of 1, which will be 1. So it's just going to be 2 plus 1, which is 3. So we know the recursion of 2 is 3. And so we can put in recursion of 2 here is the value of 3. And that's why we're printing out, at each point, we're printing out 1, 3, 6. All right. If I change my result here to be, say, 10, guess what? We should see 11. Just add that by the first value here will be 11. Bear with me. Why am I getting a syntax? Well, because I have all of this on the screen. Error. All right, so you see it's 11, 13, and 16, and you can kind of work out how we came out with that result. All right, because once we came to recursion of 0, our result was 10. All right, so now we're saying 1 plus 10, all right, which gives us 11, and then we're going up there, we're saying 2 plus 11, which gives us 13, and then we're saying that 3 plus 13, all right, which gives us 16, and that's how we have the result. All right, guys, so there you have it, a very simple example of recursion. It could be very very powerful. This is one of those concepts that again, in math, recursion is a very common concept. Fibonacci and some of those things are all around recursion. So if this doesn't make sense, guys, just play around with it a little bit more. I really hope that it comes across with this example. But I want to thank you all for watching. This really brings us to the end of this particular module. It was one of the longer modules that we've done around functions, seeing everything, some understanding functions versus methods, how to define a function, parameters versus arguments, the different ways of passing arguments to functions, like default arguments, required arguments, keyword arguments, variable number of arguments, global versus local variables, pass by reference, return statements, anonymous functions, pass statements, and recursions. It's a lot of concepts, and the reason why that is because I can tell you functions is something that's powerful within programming, and this doesn't even include system functions, right? These are all user-defined functions that we've been focusing on, and there's a whole library of system functions that Python gives you out of the box. So if you're going to add two numbers, or you're trying to print to screen, right? Print to screen, that's simply a user-defined function that Python has provided for you. All right, this print is a function too that takes some input and does something with it, but that's out of the box from Python. So in addition to all the user-defined functions that we've talked about and the different approaches, there's also a whole library of functions that you can get from within the Python syntax. All right, guys, I hope this helps. As always, all of this code will be in the description, will be in my GitHub, which is in the description below. So check that out. If you're using PyCharm, I'll highly encourage you to go out and to check out my code. What I usually do when I work on Git here is simply do a Git pull. So pull down my repo and you can get access to all of these examples. And if there are any questions, guys, don't hesitate to let me know. This is a segue into our next module, which we'll be covering next, which will talk about flow controls within Python and within programming. Again, that's a very powerful concept, and I'm really looking forward to that. All right, guys, thanks for joining. Please subscribe. Hit the bell notification, share this with somebody, and this has been Fru, your lecture for today. I will see you in our next lecture.